Sir, before you start, I have a question.
Yeah, go ahead.
Sir, I was going through one of the previous lectures in which you updated a kernel, which was last week. So there was while updating, I saw that when you were logging back into the system, so rather than the root like you have the prompt right now, it said bash something bash. So I maybe I missed somewhere. What is bash when we were opening the grub file and stuff like that?
Okay, let me reboot here. You get to see this? Did you see this when you restart?
Yes, sir.
Okay, and it was selected, right? Which one was it selected? The new one or the old one?
Old one was selected.
Okay, so if the old one was selected, then you have to set it to new. Um,
Yes, I remember it was the default was the previous one, and then we set the new one as the default. So my only question was, what is bash? I mean the prompt was changed from root to bash. So I mean, I just wanted to know what is bash.
oh, so I think what you were doing is when you were deleting, you did everything, right? Did you, when you were practicing, did you delete hidden files too?
No, sir. I didn't.
So over here, all you have is a not like this, just says bash and a colon.
Exactly, sir.
Okay, so what happens is that's the prompt you get is a bare minimum. I'll show you what happened. So if you go in here, uh, okay, hidden files. I think it's in user administration, right? So if you tell me, if you just see, ask me what bash is, then bash is a born again shell. It's just a name of a shell. What you're typing in here, what you're typing in here is they are different kind of shell. But the one we work very commonly is called bash, which is called born again shell. It's just the name. But over here, you know how you have ls-la, you have all these hidden files here, right? So these hidden files got deleted here. These are the profile that keeps your information and logs in here. This one keeps the history. Let me go back here. Where was this? This was in user administration, I think. Yeah. Okay, we remove this scale directory. Okay, here. So when we created the um, let's see here. Root VI. So this file is missing here. On your screen, do you have your computer on?
Yes, sir.
Okay, type this command here, ls-la, and then tell me which file is missing here. Dot bash rc should be missing.
Uh, yes, sir.
Okay, bash rc is missing, right?
Yes.
So where do you go is you go to cd slash etc skel skel. Okay, go in there and do ls hyphen la. Okay, and copy this file to your home directory. So pwd, how are you going to copy? Cp dot bash rc. Okay, and then what is the directory you're going to give the name? Directory name.
Sir, we're gonna go copy in root.
Yeah, copy it to your root directory, root home directory. What would be the command?
Sir, root.
Yeah, you
It
got
would
it.
be.
You got it right. Say it.
Sir, it's going to be root
No, slash root.
slash root. Sorry. Yes.
So when you do slash root, this is an absolute path. Okay, go ahead and run this and tell me if it's there. It copied and go to your slash root directory, home directory, and do lsf and a, and see bash rc is there.
Yes, sir. It's there.
Okay, so what you want to do is open new session, right click here, and say duplicate session, and then log in again. Now you should have it.
Yes, sir. It's there. Thank you.
Okay. Alright, so we'll talk about, if it says bash itself, we'll talk about it more. Bash is a scripting, we have a little scripting language built into Linux here. So we have that course will run for a good 3 weeks, okay? So we'll work on that.
Sure, sir. Thank you.
Okay, good. That was a very good question. Okay, so last week we talked about the TCP connection. TCP connection is a connection oriented connection oriented protocol. That means it has to make a connection here. It's called connection oriented protocol. So if we move on here, um, so which connection is using TCP protocol? Our SSH connection is using TCP protocol here, port 22. When we launch here, we are using SSH 22, and then we'll find out if it's a TCP or TCP connection. So the command is, you type netstat hyphen ANP, all network port, and then we're gonna go for grep hyphen W 22. Okay, why 22? Because this is a port number we are looking for. So we are using a port 22. Okay, so over here, you could see here like TCP. It says TCP. It's using the port 22 here for this uh, IP address we are connecting to. We are connecting to from PuTTY to the terminal to the server. We are using port 22. Okay, and it's a TCP connection. Why is a TCP connection? When we are making a connection, it is doing all these things here. Okay, it's doing three things. So when you go, let me exit here. So when you try to connect to the server, right? Uh, oh shoot. So 192.168.137.20. I'm gonna save it. Okay, so the moment I open this, it has already done this here. It has done this connection here. Now it's asking for a password. I'm gonna say root. Okay, this is the authentication is different step. We'll talk about that more. But in that fraction of a second, it has done all these three steps here. Sync, okay? All right, good. So we call this as a connection oriented. That means it is looking for the connection establishment. So
Sir, when I'm writing this command netstat dash anp and then grep code dash w22, it is saying bash netstat command not found.
yeah, because you didn't update your. I told you to update the operating system.
Okay, okay, sir.
So go back here. Do it. You keep the original one as is. Okay, keep this one as is, the very first one, because this is a bare bone. We just installed from the CD, and then we didn't have a GUI in there. Okay.
Sure, sure.
So
Sir, I'll do it.
go into practice and select. Uh, yeah, it was in Yum package, I think, right? I put it in the
Yes,
chat,
yes, sir, it was. Yes.
and in the chat, run this command. Okay, so run this command, copy and paste this, and do hyphen space hyphen y. That means it will automatically run it for you. So it took me. It's gonna install 2.4 gigabytes. So just leave it alone. Do like this. After
Sure, sir.
after this command, give a space and then hyphen y. So it will automatically select y to all of those. Okay.
Okay, sir.
All right. Good. You're doing good. Okay, so the port, so we are on a port 22, right? So we are using 22. So how many ports operating system has? How many ports is just a hole in the operating system to connect to it from the outside world, right? So let's see, let's do the math here. So it's a 64-bit operating system. So 2 times 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 2 times. Okay, so how many twos I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So this is a 64-bit operating system. So it's a 2 to the power of 16. Okay, I'm not going to explain this. This is your math. So operating system has 65,536 ports. And it's the same for Windows operating system also. They have that many ports in there, okay? So we'll talk a little bit more about ports. Port is nothing but, if you say port, the shipping port, right? A country has, like America, you if you're docking in, you're bringing in some goods from China, it's connecting in Los Angeles, right? Los Angeles has a port. So like that, the operating system has 65,536 ports. That means connections. Okay, any questions? So I'm gonna put down here SSH connection. Example. SSH connection is using TCP protocol and is connection oriented. Okay. All right. So you learned a new command here. Netstat -anp, and you will see this TCP. I'm not going to copy everything here. And this is port 22. Okay, so let's see here. We have on network, we're doing the NIC card, the media, the topologies, the protocols. Okay, these are the protocol here. So let's learn. There are many protocols out there. Okay, so let's learn about one more. So there is another protocol called UDP. Okay, UDP. uh, OSI is let me just make this as new below. OSI layers. Okay, and in OSI layers we have protocols. So we looked at the TCP transport control protocol, TC, uh, uh, TCP protocol. Transfer control protocol, and should I fill this up? And there is another protocol called UDP, and this is a connectionless. UDP is a connectionless protocol. Okay, so UDP, UDP. Okay, so this is a user datagram protocol. Okay, so what is this? This is a connectionless protocol. So it doesn't establish the connection, it just sends the information. It doesn't care if it received the message or not. It doesn't care, it just throws the information out on the network. Just sends the data to the host without confirmation. Okay, and the advantage is it's faster. Connection is faster. And there are two types. Okay, there are two types of UDP. Okay, hold on. Let me. Two types of UDP. Okay, so what does this mean? Two types of UDP, right? One is called broadcast, and another one is called multicast. Okay, so let's take a look here what broadcast means. Okay, so this is a good picture. Broadcast. And then multicast. I'll explain in a second what this means. So so what is happening here is it's sending out the information, the server which is broadcasting. Okay, the classic example is, think this as a radio station, and it's sending the message to the uh, to all these radios here, and it doesn't care if the radio received or not. Okay, and then multicast, think this as a FM radio. It throws out, and then only the FM radio picks up the signal. Okay, so let's see what it means here. So the signal is sent out on a network. Without confirmation. And signal is sent only to the host which are part of group without confirmation. Okay, so it's simple. In broadcast, it's just throwing the information out, and in multicast is looking at who needs this information here. So right now what I'm doing is I'm doing a broadcast here. Everybody could listen to my lecture here. But what I could do is I could select some people and then select them and put as a group, and then if I select to send it only to that group, then it's a multicast. Here I could have a group in here and then send a message to some only the group. That means it's a multicast here. Okay. All right. Good. So let's see the differences between TCP and UDP. This is TCP and this is UDP. Okay, so the TCP is connection oriented and UDP is connectionless. And TCP is reliable and UDP is unreliable. So there is no way you could have a confirmation. TCP is slow and UDP is fast. And example is HTTP and what else? FTP, SMTP, and TCP. I already showed you TCP. We'll learn about HTTP and FTP a little later, okay? And then here the broadcast is DNS, DHCP, and broadcast. So let me see if we have anything which is running UDP.
Sir, in the UDP, the DNS that you're mentioning, is it the same that like we have the DNS settings? Some people say DNS setting, I'm not sure what it is, but is it the same DNS?
Yeah,
Yeah.
it is very important. We're gonna set a complex DNS later on. DNS is the backbone of a country's network here. If for example, if hackers are gonna hack into the computer, and if they're gonna if the DNS is out for the company collapses. The whole network is down. We'll see. We'll do all that here. We'll set up DNS in here, and yeah, we do have some DHCP working here. So let's see. This is a virtual IP address is getting, and it's running on port 53. I don't want to mention this now. Um, did we talk about the router? We didn't talk about the router yet, right? Okay,
No, sir, not in detail.
yeah, the home router,
You
UDP,
just mentioned that it could have this many devices, I think.
yeah, very good,
Confirmed.
very good. Yeah, I remember that. So, so your home router is an example of a UDP. It's just giving out the IP addresses. It's randomly giving out the IP addresses, okay? But it's much more complex than that, okay? We'll talk about that a little later. Okay, so let me stop it right here. And what is the next one? Is IP address, right? Last one. Last one is IP address here. Okay, so let's concentrate on IP address. IP address. Okay, so let's work on what is IP address. Let's understand that. So let me type IP address here. Okay, yeah, this is a good example. So, IP address is an uh, internet protocol address. IP address stands for Internet Protocol Address. Is a numerical label assigned to each device connected to connected to a network, computer network that uses the internet protocol for communication. An IP address serves two main functions: host or network interface identification and location addressing. So in this scenario, this is for this computer here. If I type if config ifconfig, so this is the older command here. So we have one is a loopback, a system. If it doesn't have any addresses here, it has 1, 2, and 3 network cards attached to it here. One is this network card, and another one is built in here. Regardless what you use or not, it's built in. And third one is also a built-in virtual card here. Okay, so we're not worried about that. We are worried about the physical cards here. So we have something called 192.168.137.20. So how does this IP address work here? Let's take a look. So the number you see is 192 is actually not 192. The number you're seeing, the humans are do you ever thought of what would computer write on the hard drive? Do you know how does the computer write on the hard drive? Anybody? So the uh, computer works on a binary system. Binary system.
It just uses 0 and 1 to communicate, right?
Yeah, very good. Very good. It has only two numbers. It has only two numbers. What is that? It's called base 2. It's called base 2. Base 2 system. Okay. Well, when I say base 2 system, there is only two numbers in there, 0 and 1. 0 and 1. So the base 2 system, which has only 0 and 1. 0 and 1. Okay. And 0 means off, and 1 means on. Okay, and that's what it is here. So let's take a look here. What does it binary means? Okay, this is it. You've seen the Matrix movie, right? So it's going all this up and down here. It's nothing but zeros. So the code is nothing but it's in the granular level. It's nothing but 0 and 1. So if you go down into the computer, if you could see it, what you could see is nothing but zeros and 1. This is how the information is written on the disk. Okay, so the information is written on the disk using 0 and 1. No matter what computer you have in the world, if it's developed by Russians, Americans, or Chinese, it will be writing zeros and 1 on the disk. Okay, that's how it will remember the information here. Information is written. Information is written in binary to the disk. zeros and ones. Okay, so all right, so let's crack this here. Let's see. Let's crack our IP address. When are we gonna crack this here, and then we'll see what is actually the computer is writing on the disk here. So I said, and this is a how many bits is this? It's 128. The IP address is based on 128 bits. Okay, so based on 128 bits. Okay, so how many? 8 octets. Okay, so we're gonna start here. 8, right? Yeah. 1, 6, 7, 8. Okay, so I'm gonna see 1, 2. Everything starts from right. I think I already have showed you once here. Things starts, the computer write things from right to left. Okay, I'll tell you why in a little later here. 7, 8. And so we have 2 to the power of 8 here. So we're gonna go 2 to the power of 0. Everything starts with 0. If you go 2 to the power of 0, 2 to the power of 0, scientific. You could switch this to scientific here. You go 2 to the power of 0. Let's see, where is 0? How do I do this? You could type in Google too. You do 2 to the power of 0. So if you do 2 to the power of 0, the result is 1. Okay, so we're gonna go 1. 2 to the power of 0 is 1. Okay, and then let's go 2 to the power of 2. 2 to the so 2 to the power of 2, this would be like just multiplying it here. 2 to the power of 2 is, how do I use, anybody have used this before? 2 to the power of binary. We could come back later. Okay, so let's see, 2 to the power of 2 is 4. Okay, 2 to the power of 8 is how much? 7 is 128, right? Okay, yeah, so I'm sorry, 2 to the power of 1. 2 to the power of 1 is 2, and 2 to the power of 3 is how much? 2 times 2 times? No, 2, right? Yeah. 2 times 2 is 4. Okay. 2 to the power of, keep 2 to the power of 3 is 3. 2 times 2 times 2 is 8, right? Yeah. And 2 to the power of 4 is, now it's doubling its size here, so 16. And 2 to the power of 5 is going to be 32. And 2 to the power of 6 is, what is this? Is 64. And 2 to the power of 7 is what? 128. So that's how we reached 128 here. Okay, so where is our IP address here? Let's copy our IP address. So we're gonna plug this our IP address in here and see how this will add up.
2 to the power of 3 is 8.
Yes, 8. Thank you. Yeah. 1, 2, 4, 8, 16, 32, 64, doubling itself after 2. Okay, so let's see how this works here. So we'll just look at 192 first. 192. And we'll copy this here. Let me copy this underneath here. So I'm going to open another line here. So I'll type here 192 minus 128. Okay, so how much is left? 192 minus 198 is 192 minus 128 is, how much is left is 64. Okay, am I right? 192 minus 192, right? This is, yeah, 192 minus 128 is 64 here. I'm going to type 64 and then minus 64. Okay, and then what is left is 0. So all these other fields are 0 here, because there is nothing else to do a subtraction here. So now if we are able to use this field here, that means we'll put 1 here. We use this field 1, we use this field, we're going to put 1, and then we put 0, 0, 0, 0, 0, 0, 0. Why are you putting 0 here? Because we haven't used this field here. So if we use this field here, this is what we're going to do here. So our 192 is The result of 192 is 11000000. Okay, good. All right, let's do it to 168. And I'm going to put this what we have determined here down here also. I'm going to keep some room here. And okay, so let's start with here. We do 168 minus 120. 168 subtract 128. Okay, so how much is left here? 168 minus 128 is 40 is left. Okay, 40 is left here. So if we use 40 minus 64, we are not able to do that. So if we use this column here, we're gonna do 1. Can we technically we cannot subtract 64 out of 40, so we're not gonna use this. We're gonna use 0, and we're gonna carry over 40 here minus 32. So we're gonna use this column here, so I'm gonna put 1 here. Okay, so how much is left? 40 minus 32 is 8 is left. Okay, so can we use 8 minus 16? No. So I'm going to put 0 here. Okay, so 8 has traveled here. 8 minus 8 is 0 is left. So did we use this column? Yes. And what is left is 0. 0 is left, 0 is left. So we're not using these columns here. So 0, 0, 0. So 68 is 1 0 1 0 1 0 0 0. This is how the computer is going to write to the disk. 68. Okay, so 137. So okay, so we have 137 here, right? 137 minus 128. So we use this column here, so 1. So 137 minus 128 is 9 is left. So 9 is left. We are not able to use this column. 9 get transferred here. We're not able to use this column. 0. 9 again. And then it's 0. Here we could use it. 9 minus 8 is 1 is left. So we are using this column. 1 is here. So we cannot use 1 minus 4 is we cannot use that. 1 minus 2 we cannot use that. And we could use 1 minus 1. Okay, and we use this column here. So 37, when system is writing, it goes to 1 0 0 0 1 0 0 1. Okay, this is how the system writes this to the to the disk here. And what is the last one is 20. 20. So 20 is left. So obviously we're gonna put 20 here, so we cannot use this. So 0, 20 get carried here, we cannot use this. 0, 20 over here, we cannot use this. 0, So we could use 20 minus 16. We use this column. So I'm going to put 1. 4 is left. We cannot use it, so I'm going to push 0. 4 carries over, and then 4 minus 4 is, we could do that. So I'm going to use that column, and 0 is left, so nothing. 0, 0. So in reality, the system writes to the disk. This is how it writes. 20 is written as 0, 0, 0, 1, 0, 1, 0, 0. Okay, so your IP address is, what is your IP address here? So this IP address, this is what it looks like to the computer. Okay, this is what it actually computer writes it to. Okay, so let's put in Google and see what is this here. I think okay, even all the text and everything, it could be converted into binary here. So we'll just see, we're gonna plug in our rapid tables input text. Uh, 100. No, this is not right. Binary. Okay, decimal. Okay, let's copy our binary here. Let's copy the whole thing, see if it's going to give it to us. Decimal to binary. I think we may have to just do this 192. Okay. Let's look at only 192 and if it stands true. 1 1 followed by 2 4 6 zeros. Okay. So when we type 192, yep, that's what we got. 1 1 followed by 6 zeros here. So 168, let's do 168. And then 10 10 10 followed by 2 zeros, right? So 10 10 10 followed by, yep, that is accurate also. 137. Okay, so we have 1000 and 1001. So we have 1000 and 1001, and let's go ahead and do it for 20, and so you have 100001 here, binary. Okay, so let's see here. It's showing only 10 1 0 1 0 0. Okay, it's not for us. It's not giving good output here, but remember the information we have here is much more accurate here, because leading zeros means something in the computers. Okay, for example, if you type 100, if you have like two zeros in front of a number, if you have 100, if you have 00100, how do you read this? This is $100, right? Yeah, it'll be the same thing as 100. But in computers, 00 leading zeros makes a difference here. You have to, it is a valid option, okay? So now why is this writing from left to right here? Because when you type in here in Google, you type numbers, so oh god, so you type it's the numerals. What do we have? 0 to 9 is numerals, right? So the way the modern numbers, these are the numbers here. If you look at the numbers, this is what it's coming here. So if you type Roman numerals, so Roman numerals are, these are the Roman numerals, 0 1 1. So but the computer doesn't use this. What does computer use is Arabic. Computer use Arabic numerals. So these are 0 starts with 0 to 9 is numerals here. So but what does the Arabic language? Arabic language starts from left to right. I'm sorry, right to left. So Arabic, if you type in here, it goes from right to left. So that is why happening here is so the computer understands the Arabic language, so that's why it's going from right to left. Okay, is that clear? Okay, so I think we did a lot today. Uh, okay. All right, so let's move on. The next topic we're going to talk about is the gateway, and then it has to do with uh, the router. Yeah, we have enough time here, right? Yeah. Okay, so default gateway. Let's copy this. So we have something called router, right? Everywhere a router is there. So your home network has a router, and it gives out router gives out IP address to another device. Okay, and how many IP addresses are there? There are total of 256 IP addresses are available. Are available. Okay, and one IP address is reserved for router itself. So this box is giving out the IP address to other devices, but it's saving itself one IP address, right? So if I do IP address, IP config, so the default gateway is the IP address of the router here. So if you find the default gateway and then you type it in here, mine is not going to work here because I'm using something different. I'm using a Wi-Fi, so it won't allow me to do that. But go ahead and bring that this up here, command prompt, and type ipconfig in there, and then you should see your router's IP address here. So that is the reserved IP address for this, for itself. Okay, so each router is a subnet in itself. Okay, that means each subnet can have total of 256 devices maximum. So let's see here. So we are at 2 to the power of 7 is 128. So this one is 256. So this is 2 to the power of 8. 2 to the power of 8. Type 2 to the power of 8. 2 to the power of 8 is 256. Right? Yeah. This is a base 2. So based on zeros and 1. So these are 256 devices it could support. Okay, so how do you check the default route in your system? You type netstat -rn. So when you type it here, it will give you the gateway here. Okay, type netstat -rn and it will give you the gateway. Gateway is the default gateway. And this is the default gateway. So how is that coming up here as default gateway is, if I go into my system here and if I go to my Ethernet and if I look at default here and it says the IP address is 192.168.137. The setup I have here is a very weird setup here. Don't look at mine, but go ahead and look at yours here and it should give you the IP address. Okay, so this is the one. This is the IP address. I'm have a weird setup here, so I'm sharing this IP address here as a default gateway. Let's see here what this one has. Okay, so this one is a different IP address, and the default gateway I think is 10.132.32.0.1 here, right? This is what we got. Yeah, 10.232.0.1. So for this connection, the default gateway is 10.232.0.1. So this information is accurate here. Okay, so what else? Route. So this is the IP address assigned to the each device here, right? So I could ping here I could try to ping um, I could try to ping this from here. Ping 192.168.137.1. So it's pinging. The IP address is pinging. Ping 192.168.137.1. Okay, so what I'll do here is I'll see I'm gonna pause for 2 minutes here. Anybody has any questions here? Okay, so here the router has only 4 ports here, right? So if this is a Wi-Fi router, all the 56 IPs, 256 IP is including either the physical port or the IP addresses or the Wi-Fi. Okay, if you have like 1, 2, 3, 4, these are 4 ports here, and if you add a switch in there, what does switch do? Switch is nothing but it's just a dumb. It's not a router. Switch is not a router. It's just a switch, right? So usually routers, they don't have many ports in here. You use the switch to make up more ports here. So for example, if I copy this, so how many ports we have here already? How many ports I have? How many usable ports I have? One is reserved. How many ports we have here? 4, right? And if I add this switch here, it has 1, 2, 3, 4, 5. So now how many total ports I would have? Physical ports?
So 20. Well, I mean, if we put in every switch, right now we'll have 4 plus 5, 9.
Yes, very good. We have 9 ports. But the switch is dumb here. Switch is just extending the router's capability. Switch doesn't assign IPs. Okay, remember that. Switch doesn't assign IPs here. This is much better here. Let me copy this. Switch is just helping with the ports here, okay? So it doesn't assign IPs. Okay, good. So we are good there. So I'm gonna put in here commonly used ports and their IP addresses and their port numbers. What do they use for? Okay, so okay, yeah, this looks good to me. Let's say 53 is there. 53 is there. DNS. 22 is there. SSH secure shell. I want to make sure everybody got the concept of ports, right? What port is and a port number. Port is nothing but a port, like a shipping port, and got a number to it. Uh, okay, so let me. Yeah, I think I got it. Yeah, it looks ugly here. Give me 1 second here. Let me just cut it out. Yeah, this is better. So don't worry about this here. You're not gonna be have to remember this all the time, but you just have to remember this. So the port TCP, these are the TCP protocols. Most of them are TCP here. Let me see anything is UDP. Uh, I think it tricked me here. Let's see. Common TCP and UDP port used by Red Hat. And these are Unix specific. Well, don't worry too much about it here. So we'll remember what ports we need to use as we um, move with the flow here. Okay, so let me close this. So next thing I'm going to show you is how to do the network bonding. It's called NIC bonding. Okay, so let's see what I'm going to show you is yeah. So we're gonna say it's called NIC bonding. NIC bonding. So we're gonna take two network adapters and we're gonna bond it together so that what it happens is we're gonna bond it together, and what it will happen is it will, if one network adapter fails, the other one will keep it active here. Okay, so we'll see how it goes. I forgot to put the date here. Okay, so what is NIC bonding? Okay, so what we'll have is, let's see if we could find the picture. NIC bonding. Yeah, this is good. So what we got here is a network bonding. I'm sorry, NIC, network interface card bonding. Okay, so we have this server here, and in this server we have two uh, two addresses. I'm sorry, two network cards in here. If one goes down, another one will pick it up here. Okay, so we'll see how it goes. So if I do IP ADDR, IP space ADDR, so we are looking for the physical network here. We have only one, ENP0S3. So what I'm going to do is I'm going to go ahead and add another one here to this. I'm going to go into settings and network, and I cannot add the second one in here, right? So let me shut it down. So I'm going to edit this in Paint. Oh, God. So the one we're gonna have is ENP0S3 and S8. Okay, so let me just put this one in here, and I'm gonna make it bold. Okay, so what I'm gonna do is I'm gonna go into VirtualBox, and I'm gonna go ahead and go to Enable and Bridge Adapter, and also make sure we're not using NAT or anything else anymore. Host only. We are using a Bridge Adapter only. I think I put that in the last class, right? Right here, Once you update to the GUI, we are using bridge adapter going forward. Okay? Make sure you make that change when you're practicing it. So we have two adapters here, adapter 1 and adapter 2. So make sure they're all the same. For some reason I have two of them. Most of the time you should have only one. So select the one which is default already. I'm going to say Intel. Okay, and then I'm going to Control P. Alt parent. Okay, VirtualBox. Okay, I'm going to go ahead and restart. Did I talk about switching back from switching into GUI mode and then the regular mode, multi-user mode? I think I already did, right? Yeah, right here. Init 015. If you want to go into multi-unit mode, you just type init 5 in here and it will change there. I'm sorry, if you want to go into graphical mode. Okay? So if I type init 5 here, it will switch into graphical mode. And of course you have to update the way I told you. Yeah, we're not worried about it. Let's run that in the background. So if you type IPADDR, now we should have 8 here. ENP0S8 and ENP0S3. So what we're gonna do is we're gonna do combine and make it bound. We're gonna bind it. Bonding means binding it together, and then only one IP will be available here, but it will be used with two Ethernet adapters here. Okay, so one goes down, other one will automatically pick it up. Okay, so how are we gonna do that? This is a pretty advanced topic here, so you concentrate what I'm doing here. Okay, so let's go in here.
Sir, I have a question. What is the exact reason for this bonding? I mean, why are we doing this?
Yeah, if one right here, very good question. So this is how it is. There are two ports on the system here, right? Would you agree? This is a system.
Yes, sir.
Oracle, for example, this is a Oracle server, okay? And we have one Ethernet adapter, and we have a second Ethernet adapter, and one is connecting to a different switch, another one is connecting to another switch here. So if this switch goes down, the IP address goes, this network adapter goes down, so the IP address goes down. Okay, but since we are doing bonding here, it will pick it up here. This will be active here. It's a fault tolerant.
Okay, sir. Okay.
It's a fault tolerant. Is if like airplanes, they have four engines, right? Technically, airplane could fly on only one engine. If they have like they have if one engine goes down, nothing happens technically. It could continue flying. So if you're driving a car, your car has two engines. One engine goes down, nothing happens. You keep driving. I don't know when that will happen, but you got the concept, right?
Yes, sir.
So if the server cannot afford to I mean, what you're doing here is putting this on a two different switches and two different networks. You're just avoiding the network failure. Okay, so where are the network configuration files are? Where the network configuration files are? I already showed you this. NIC configuration. This is a single configuration here we did. And network configuration file is in this folder here, okay? So I told you etc folder is nothing but a configuration folder. Okay, so let's go in there. cd/etc/sysconfig network scripts, and you do ls-l. Oh no, don't do that. You do ls. Okay, and here you have adapter 1 and adapter 2. Okay, and using bridge network. Network and using same network port. Okay, so you go in here. So these are the ones we are focused on. These two files. It may be a different here, so don't freak out. It may be a different for you. Don't freak out. Okay, this is one, and this is. I think the time is up here, so I'm gonna stop here. We'll catch up tomorrow, okay? And I think some people are not joining, right? Who's not joining? I think Greg is not joining. Either John or hey,
Online, sir.
what?
I'm present.
Oh, you. Oh, okay. What are you logged in as? I see. Hey, John.
Hey, fam.
Oh, that's hey. Okay. Oh, okay. Good. All right. So I'll stop it right here, and then we'll pick it up we'll pick it up tomorrow. And then whenever this is ready, I will upload it. Okay.